What if the most powerful force shaping your future weren't politics, economics, or even biology, but code? From the apps on your phone to the systems that guide aircraft or move financial markets, software is no longer just a tool. It's become the invisible architecture of life, amplifying human intent into global action. Code doesn't just create simple apps or online platforms. It dematerializes whole industries, alters how societies are governed, and even extends into consciousness itself. A single algorithmic tweak can make or break fortunes, shift public opinion, or rewire habits at scale. With trillions of devices already sensing, deciding, and acting, the world we inhabit is increasingly cybernetic, a fusion of human and machine, biology, and computation. Today, you'll explore how this fusion is transforming everything from smart cities and cloud platforms to brain-computer interfaces and drone swarms. You'll see how history's long cycles of inequality persist, why privacy has collapsed, and how new technologies of freedom point toward alternatives. Above all, you'll discover why the future of the Cybernetic Society isn't fixed, but depends on the choices we make about empowerment, freedom, and control. Cybernetics emerged in the mid-20th century as a science of feedback, control, and communication linking humans, machines, organizations, and even cities. The mathematician Norbert Wiener, influenced by the physician Arturo Rosenbluth and the physicist André-Marie Ampère, argued that no system could be understood in isolation. Human thought and mechanical processes were fused into loops of decision and action. Today, that vision has matured into a cybernetic society, a world where every layer of life, from households to megacities, functions as a feedback system. What makes this condition distinctive is reflexivity, the way digital signals fold back into the physical world and trigger spirals of consequence. In finance, not only do high-frequency algorithms predict prices, they also move them, producing shocks such as the 2010 flash crash. On social media, a single post can be amplified until it reshapes politics and culture. Human intent and machine response continually reinforce one another, turning private gestures into systemic forces. These effects can often feel abrupt due to exponential growth. Long periods of gradual buildup give way to tipping points, when hidden thresholds are crossed and change cascades suddenly. Neural networks, for example, lingered as academic curiosities for decades until data and computing power scaled. Then, over the 2010s, they began powering everyday tools, from chatbots to self-driving cars. The same nonlinear leaps define platform adoption, automation, and planetary-scale infrastructures. The very same feedback logic reshapes organizations and even cities. Firms behave less like static hierarchies and more like organisms, sensing and responding through loops of information and action. Predictive maintenance in industry and AI-managed logistics in cities show how decisions can emerge from streams of data rather than top-down plans. Neom, Saudi Arabia's planned megacity, is conceived as a cognitive city that continuously adapts to residents through AI-driven transport, energy, and governance, even experimenting with decentralized decision-making. Like an organism, it is designed to sense, act, and learn in real time. All of this sets up a central tension. Cybernetics can extend human agency, embedding intelligence in firms and cities, yet it can also erode privacy, amplify bias, and enable opaque systems of control. The opacity of machine decisions and the tendency of humans to rationalize after the fact make explainability and mechanisms of error correction essential. Whether feedback empowers or coerces will define the path ahead. A world fused through different feedback sources may become more resilient and creative, or more brittle and coercive, depending on how its systems are designed and governed. If companies are becoming cybernetic organisms, cities are following suit on an even larger scale. Neom, Saudi Arabia's $500 billion experiment in cognitive urbanism, shows what happens when entire urban environments are designed as feedback systems. Its promise is striking: optimized resource use, predictive maintenance, and commutes tailored for efficiency and well-being. Yet the same networks of sensors and data that make this possible could just as easily enforce constant monitoring and control. Smart cities embody both promise and peril. Beneath these futuristic skylines lies the gravitational pull of the cloud. Amazon already blends 1.5 million employees with around 750,000 robots, automating logistics and even terminating contracts by algorithm. Its cloud platforms, together with those of other dominant firms, now provide the computation, storage, and AI that much of the digital economy depends on. These systems are becoming a foundational backbone for commerce, governance, and communication. The scale of these projects also locks in their trajectory. NEOM's projected $500 billion cost means it cannot easily pivot once the foundations are laid. History offers a parallel in Motorola's Iridium satellite network, an ambitious idea burdened by sunk costs that made adaptation nearly impossible. In both cases, once a platform is built, alternatives narrow. Path lock-in means today's efficiencies can become tomorrow's constraints. The deeper point is that infrastructure is political. Economist George Gilder reframes capitalism as an information system in which progress comes from surprise, unexpected innovations that jolt the system forward. Cybernetic infrastructures determine whether those surprises will flourish or be stifled. They decide whose values are embedded, who controls data, and who reaps the benefits, whether power will be centralized in platforms or diffused across citizen populations. The next frontier is more intimate still. Cybernetics working not only through cities and corporations, but through human bodies themselves, where machines intertwine with our senses and decisions. That's up next. Imagine sitting your final exam not in a hall, but in your living room. A sleek headset rests on your head, and with a thought the walls dissolve into a vast digital valley. This is no daydream. A brain-computer interface is teaching and testing you at once, monitoring your focus, and adjusting the puzzles you face. When you hesitate, it offers hints. When you excel, the challenges grow harder. The exam feels more like you're expanding your mind than using a device. A continuum of brain-computer technologies runs from non-invasive EEG caps, cheap but imprecise, to electrocorticography or ECOG arrays that sit directly on the brain's cortex to microelectrode implants that record individual neurons and can restore movement. Cortical recordings such as ECOG have even enabled the synthesis of speech directly from neural activity. Each step upward increases fidelity, but also risk. Firms such as Neuralink, Kernel, and Paradromics are pushing these frontiers, promising breakthroughs in medicine and communication, while raising pressing questions about long-term safety, class divides in access, and how much of ourselves we are willing to merge with machines. Augmentation extends beyond the brain. Exoskeletons like UC Berkeley's Bleaks have reduced the metabolic cost of walking by 1 to 22%, enabling workers, soldiers, and rescuers to keep going when biology alone would force them to stop. Military programs like the U.S. Talus suit or Russia's Rostec designs aim to boost load-bearing and endurance, reducing strain during prolonged operations. In these cases, decisions once bound by biology, to rest, to lift, to endure, are reshaped by cybernetic extensions. They promise resilience, but raise dilemmas over responsibility, inequality, and the ethics of designing super soldiers. On the battlefield, augmentation accelerates into hyperwar. Here, autonomous systems compress the OODA loop, observe, orient, decide, act, from minutes to seconds. The U.S. Defense Advanced Research Projects Agency, DARPA, envisions swarm programs with hundreds of drones coordinating with minimal oversight. China and Russia are already experimenting. In Ukraine, officials estimate Russia alone is producing tens of thousands of first-person view, or FPV, drones per month, while both sides deploy unmanned aerial vehicles, or UAVs, to spot artillery, strike armor, and even attack warships. Naval drones and loitering munitions, sometimes called kamikaze drones, have flooded defenses. In Gaza, Israel has deployed loitering munitions such as the Harap alongside smaller UAVs and robotic ground vehicles, backed by AI-driven surveillance. The same feedback loops that adapt your exam also enable swarms to hunt targets at machine speed. These cases reveal the gulf between principle and practice. The U.S. Department of Defense articulates 5 ethical AI principles: responsibility, equitability, traceability, reliability, and governability. Yet on the ground, the shift toward autonomy is undeniable. Without clear governance, cybernetic warfare risks amplifying destruction as much as it extends human capability. The frontier of augmentation isn't confined to soldiers or students. The same feedbacks that reshape learning in combat are also spilling into civic life. Next, we turn to the deeper historical cycles with which they interact. What if history itself followed patterns, rising and falling in cycles like tides? That's the claim of cryodynamics, a field created by the Russian-American scientist Peter Turchin. Drawing on data, mathematics, and history, it looks for recurring rhythms in how societies grow, prosper, and unravel. Turchin argues that instability is rarely random. It comes when inequality deepens, populations strain resources, and elites multiply faster than positions of power. To track these dynamics, cryodynamicists use the political stress index, which combines income inequality, elite overproduction, and state finances. When the index rises, the risk of unrest grows. Technology, far from smoothing these rhythms, accelerates them by mass-producing educated elites and concentrating wealth at the top. Turchin calls these long, secular cycles, multi-century waves of integration and disintegration, prosperity and decline. This pressure is now visible. In his book, End Times, Turchin warns that the United States shows the same warning signs as past collapsing empires: elite fragmentation, economic decline of the working and middle classes, and deepening polarization. More broadly, cryodynamic research suggests many societies may be entering turbulent phases of their cycles, long waves of disorder and rupture that have repeated throughout history. Even if societies could steady these cycles, another trap awaits. Privacy has already collapsed. We are permanently opted in. Attempts to step back are futile. After the Snowden leaks, even the Kremlin reverted to typewriters to avoid surveillance. But researchers have shown that keystrokes can be decoded acoustically, proving how even analog tools leak signals. Everyday apps like Strava or Waze, the latter owned abroad and mapping U.S. drivers in finer detail than domestic law enforcement, turn movement into exploitable patterns. Smartphone defaults share data by design. Cloud drives archive files long after users think they are deleted. Regulation, such as the EU's GDPR, has barely dented the dominance of Google, Amazon, and Microsoft, whose infrastructures centralize data and power. Together, cycles and surveillance define the hard limits of our cybernetic age. Historical rhythms of inequality and unrest continue, now accelerated, while privacy's collapse leaves citizens exposed and constrained. Yet cycles aren't destiny. Innovation often arises from recombining old parts in new ways, offering societies feedback-driven exits from otherwise tightening traps. If opting out is impossible, the only way forward is to explore countermeasures, technologies of freedom that decentralize power and restore agency. Husain remembers an evening in Austin when Sir Tim Berners-Lee, inventor of the World Wide Web, described his next project over dinner. Berners-Lee's idea was simple yet radical: give every person a private pod to hold their own data, and let them decide who gets access. That vision, solid, captures the spirit of what Husain calls the technologies of freedom, tools that return control of code, data, and infrastructure to the people who use them. This principle can already be seen in action. Community-built internet networks like NYC Mesh let neighbors connect through rooftop antennas instead of relying on telecom giants. If one antenna fails, the others keep talking, creating resilience that centralized providers can't offer. In the same way, self-hosted services like Nextcloud make it possible to run your own email and file sharing, keeping your data on machines you trust. Other platforms experiment with data dividends, where you contribute information and receive a share of the value it generates, flipping the script on surveillance capitalism. Even artificial intelligence can follow this path. With federated learning, your device trains AI locally and shares only the results, never your raw data. Google's Gboard keyboard already uses this approach, improving predictions while keeping what you type on your own phone. And on the security side, researchers are preparing for quantum computers by developing quantum-safe algorithms such as Kyber for messaging, Dilithium for digital signatures, and Sphinx Plus for authentication. These are designed to withstand tomorrow's code-breaking machines. Identity and governance are also being reimagined. Decentralized identifiers let you prove who you are without relying on a central authority, while verifiable credentials work like digital passports you fully control. And decentralized autonomous organizations use blockchain contracts so communities can vote transparently and run projects together, whether it's managing digital currencies or virtual worlds. Beyond the digital, the same feedback logic powers community microgrids like the Brooklyn microgrid, which lets neighbors trade electricity directly, and participatory platforms where citizens guide budgets and policies. All of this only works if people have the skills to use it, which is why digital literacy campaigns from the Philippines to the UK and Singapore are teaching privacy, security, and critical thinking. One project shows how far these ideas can stretch. In Lahore, the -15 project uses sensors, mesh networks, and blockchain incentives to cool the city's scorching climate, turning community action into measurable environmental change. These experiments don't guarantee freedom, yet they point toward technologies you can steer rather than those that steer you.